Alright, hello once again, Jeff Scott of Rankin Technical College. And again, as part of the Rankin Technical College AWD1100 or C# language programming class, I've been doing a series of video presentations based on our textbook for the class, which is Muroc C# 2015. So far, in the class itself, we have already gone over chapters 1 to 3, 4 to 11, and I've done presentations on chapters 12, 14, 15, and 16. We're skipping 13. Now I want to go through and finish up by going through 17, 18, and 23. And I'm in the middle of chapter 17, which is an introduction to database programming. So that's what I'd like to get back to right now. Okay? We looked at this last time, and I mentioned to you that there are 1, 2, 3, 4 fields in here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 records in here, if I have done my math right. Each one of these fields is made up of 1 or more characters. Each one of these records is made up of 1 or more fields. This thing collectively is a table. So each table is made up of 1 or more related records. If I can have a database which is 1 or more related tables that's as small as 1 table or as large as several tables. So, as mentioned right here, a relational database uses tables to store and manipulate tables. Manipulate data, I should say. Each table consists of 1 or more records. Records are called rows. They're also called tuples. T-U-P-L-E-S. That's more an international type of term. Each row contains 1 or more fields. Fields are also known as columns. Most tables contain a primary key. And again, a primary key is a unique record identifier. So each record in here has a different product code. So product code would be a natural in here for a primary key. If by chance I had 2 product codes that were the same, then that field couldn't be a primary key. I'd probably create a new field called product ID, where I could be sure that each field that was in there was given a unique number. Some database management systems allow you to define non-primary keys. In other words, they're called unique constraints. As an example, what we talked about before, let's suppose that I am storing a social security number in a database. All right, but I don't want it to be a primary key. Why? Because as I mentioned to you in the previous lecture, primary keys should be unintelligible. Again, that means that if somebody finds out your primary key, there's nothing they really should be able to directly do with it. And that wouldn't be the case if it was a social security number. But I could put a unique constraint on a social security number, meaning that each one had to be unique in the table. Tables can also be defined with indexes. And indexed is used basically internally by the database so that when you're looking up data, all right, the system can find it faster. Now, when you create a primary key, that field is automatically indexed. When you create unique constraints in most database management systems, the unique constraint fields are also indexed. But an indexed is not that different from an index in a book. If I wanted to find out primary key in my book, in my C# book, what would I do? I'd probably go to the index and look up primary key to see what pages somebody, the author went over it. All right, so here's 2 different tables. This is a much better example than the one I showed you before. All right, this first one is an invoice table. So this is the invoice ID. All right, that's going to be, basically that's the number of the invoice, whatever you want to say. This is the customer that had that particular invoice. Notice it's a customer ID. You don't want a customer name in here for the same reasons I showed you in the last lecture. There could be misspellings and the like, and you just don't want to do that. All right. This is the date of the invoice, the total amount the invoice cost, the sales tax for that invoice. Remember, different states have different tax rates. The shipping, which again, different states can have different shipping rates, and the invoice total. What's that invoice total? The product total, all right, plus the product total times the tax rate, plus the shipping cost, I believe. So this would be $57.50. If I did the multiplication there, that'd be about another $3. All right, and then another $3.75. So that's this table. Then down here, we've got the particulars for each invoice. So invoice 41 had this product code at this unit price and a quantity of 1. You'll notice that the only one in here that's a little bit different is the last one, because it has a quantity of 4. Now, this item total, that is this times this. But what I want you to understand is I have a field called Invoice ID, all right, and that Invoice ID is unique on every row in this table and in this table. No, it's not. Look, 47. So now we cannot use, the invoice ID can be the primary key here. No problem. But it can't be here because it's replicated. 46, 46, 46, 46. See that? 47, 47. We can't do that. But what we can do if we want to is make what's called a concatenated primary key. A combination of the invoice ID and the product code, because each one of those combinations is unique. All right. So the tables in a relational database, they're related to one another through their key columns. A column that identifies a row in another table is a foreign key. A good example is the one I showed you previously, not so much the authors, but this one I showed you. The department number here would be defined in here, and each department number then would have a name. Now, let's say that I work for a company that has 57 different departments. And I know the department I work in, but I once in a while deal with people from other departments, and I have no idea what their department number is. I can come in here and print out all the information from this table, and it'll show me each department number and the name that goes with it. All right. Usually a foreign key corresponds to a primary key in a related table. All right. And it says in SQL Server, however, a foreign key can also correspond to a unique key in a related table. Okay. When two tables are related using a foreign key, the table with the foreign key in it, remember that's a field that you copied from one table to another, so you're able to do what's called join the tables together. So the one that you added the foreign key to is called the foreign key table. The one that you added the field from as a primary key, where it's a primary key in the other table, it's called the primary key table. Sorry if that sounded confusing. I think when you see it in action, it'll make more sense. All right. Now, you can have 3 different kinds of relationships with your tables. You can have the best kind, which is a one-to-many relationship. That's the best kind you can have. All right, what does that mean? Looking at that example that we looked at before, okay, this is a one-to-many. So each one department number that's in here will relate to 0 or more employees over here. So an employee can have only one department number, but every one department number can be used by 0 or more employees. That's a one-to-many. All right. The worst kind of relationship you can have is a many-to-many. When you have a many-to-many relationship, because most relational database management systems cannot handle many-to-many relationships well, you break it down into a series of one-to-many relationships. A one-to-one relationship, the other kind, is what I showed you here. There is a one-to-one relationship between this table and this table. Why? Because it's the same relationship. Typically, if you want to see whether or not you've got a one-to-one relationship, you say, hey, could I take all the fields from this table and put them into this table without any problem? And the answer here is yes, you could. All right. The Server Explorer design window. Well, the idea behind this is as you start to create your table, depending on the tool that you're using to create your table, this is an example of one of those tools. So we'd say that these are the names of the fields that will be in our table. Invoice ID, customer ID, invoice date, product total, sales tax, shipping, and invoice total. These will be the types of data: whole number or int, date, time, and these are all monetary fields or decimal fields for us. Allow nulls. Notice that none of them are checked. If they're checked, you can never check. This little symbol here means that's the primary key. That can never allow nulls. Any of these could conceivably allow nulls. Null means unknown. You also can set default values, not for a primary key, but if I knew that 90% of my business was done by customer 123, I might want to set that as the default. So here are some of the different data types that you can use. A bit is more, not even a byte. A bit is typically used for our equivalence of a Boolean. A bit can be 0 or 1, where 0 is false, 1 is true. A char, which is a non-variable length field. So typically, like I would say for state, I would say char 2 if I was going to be using the 2-character state abbreviation for each state. Varchar, all right, var is for variable length. And over time, varchar got kind of screwed up, and they started coming up with nchar and nvarchar. We'll talk about them at a later time. Date time, decimal or numeric. Float, meaning it can have a decimal place. Different kinds of whole numbers, those being big int, small int, tiny int, and monetary fields. So they're going to be working in this book with a database that, as you can see, has 6 tables in it. Now, you may or may not have noticed, but one table, that table being order options, is an island into and of itself. In other words, to my knowledge, sales tax rate does not appear in any of these tables. First book ship charge does not appear in any of these tables. Additional book ship charge does not appear in any of these tables. But I can grab information from these 5 tables by joining together, for example, these 2, or these 2, or these 3, or these 4, type of an idea. When we do that, all right, let's put some more terminology here. First thing I'll talk about is DDL. And the next thing, in fact, yeah, we'll do DDL. Then we'll do DML. So what are those? DDL is Data Definition Language, used for identifying what's called the schema. Guess what? You've already seen schema. An example of schema was this. Our names, our types, whether or not we allow nulls, etc. All right. There are 3 SQL keywords that are associated with DDL. Those are create, alter, and drop. When I want to be able to add a new schema, create something new, add a new table or whatever, I'm going to use create. If I discover that maybe in my schema, maybe I spelled first name wrong or I didn't make it big enough, that would be an alter. If I no longer need a schema, I would use a drop. All right, then we have DML, which is data manipulation. Whoops. Language. And as it says, that's for the data. That involves create, read, update, and delete. And if you take the first letter from each one of those, it spells CRUD. So if you've ever heard of CRUD operations, that's what they are. More often than not, we look at them as being oops, what did I do there? We look at them as being a select, update, insert, and delete. So the select is like a read, the update, of course, an update, the insert with create, and the delete with delete. All right. So this is CRUD, and the reason I put them in this order is S, T, U, P, I, D. It's never caught on, but where that's CRUD, that's stupid. All right. Oops. So we just looked at a couple of those. Here's an example of a select statement. Just so you know, everything, and I mean everything that's in here, is case insensitive. All right? Many people like to take keywords like select, from, where, and order by and capitalize all of them. But this should work in virtually every DBMS, whether you put in WA in uppercase, lowercase, or mixed case. So what this says is, what I want you to do is I want you to go through the customers table, which is here. Notice there's a customer ID, a name, an address, a city, a state, and a zip. And I want you to go through that customers table and give me the name and the city of everyone who's in my customer table who lives in Washington. And there it is. We're ordering it by name, which means that this is in alphabetic order. All right. If we had instead ordered it by city, all right, then your Seattles would be together, your Olympias would be together, etc. When you do a select statement like this, you're not changing any data. This is like, remember we had a getter and a setter that we've talked about? This is a getter. So when you write a query, which is what that we just looked at, with a select statement, what you get is called typically a result set. The select clause, as it says, lists the columns that should be included, and they can include calculated columns if you want to. So you can do math. The from clause names the table or tables that the data is retrieved from, and the where specifies criteria. So if we left this where off, we'd get the name and city of all customers, whether they were from Washington or not. If you want to select everything that's in a table, you say select star. It's a shortcut. Typically, you don't need everything, but you might. So here's the syntax for joining two tables. Now, when you start to look at that, you're like, oh my gosh, this is I'm never going to get this. All right. Well, let me show you if I could. Can I grab this? I don't know. I should be able to, though. Right, I'm going to just grab all that information that's right there. Why? Not to waste my time, not to waste your time, but there is a little faster way you can write this. Now, even faster is not the best way to put it, but I'm not going to say better because, again, when you do this stuff, how you do it quite often is going to be up to you. All right. So notice we've got here, this is what's called here fully qualified. I've got the name of the table followed by the name of the field. All right. Let's say that I change this and I put here from invoice line items. I'm going to say here as ILA, invoice line items. Inner join products as P for product. Now I can change this to ILA every time I've got this in here. That one I've got to leave. And all my products now become P. Except for that one. Now, you may or may not agree, but that's a little bit easier to read and be able to tell what's going on here. You see how you can separate stuff over multiple lines too. All right? This is an example of what's called a join. So what I'm saying here is I want you to go to the invoice line item table, and it should have been invoice line ILI, not ILA. I don't know how I got an A there, but I did. Which means I've got to change that one to an I and that one. All right, so that means go to the invoice line item table and grab that field, that field, that field, and that field. Also, go to the products table and grab that field. And you can do this because the field that's called product code exists in both tables. And I want to grab that information from both tables, but only the ones that have an invoice ID of 46. Again, not going to probably make a boatload of sense until you're working in this in a little bit more depth and breadth of coverage. All right, so a join, as it says, allows you to combine data from two or more tables. The most common type is the type I just showed you. It's called an inner join. All right, where there's matches in both tables. Okay. Check again here. Wow, I'm already up to 23 minutes. Okay. I'm going to stop right here because I'm at 24 minutes. All right, and I'll pick it up in just a bit.